Welcome back to the last session of WITS. So our first speaker will be Favonia. So take it away.
Hi, hello everyone. So I'm going to introduce a OCaml library called asai, which is for compiler diagnostics. And I appreciate all the many speakers before me because they basically introduced how important compiler diagnosis are. So I don't have to repeat that. I only have to just show out what we have done under that assumption. So you might wonder why we have this name. Unfortunately, I measured the time. I do have like at least 10 jokes that hidden inside of this name, but I'm not able to do it. But so anyway, so we're going to move on. So think about a typical implementation day. So you are exhausted after listening to all the purple talks, and you feel like you have absolutely no energy whatsoever to implement error handling until you see this. Okay, this is a typical OCaml thing if you are just using some minimum way of the kind of raising the exception. And you're going to have this, and with all these lines which are not helpful at all. Okay, then you talk to yourself, okay, I have to implement something, even to myself, to understand what's going on. So then when you are trying to implement compiler diagnostics, and then you have to worry about many things. And in particular, in our case, we are trying to build a general library which should be, usable in many cases. So we have to think very hard about what constitutes a good compiler diagnostic. So the first thing, like a mechanism should provide is to determine whether a program should terminate now. Whether it's something that you cannot recover and you should just give up, or there's just some message that you want the user to know and then you should move on. That's something that you have to decide. And the other thing is, how serious should the user take it? Is it an error, is it a warning, or just some info or some kind of tip that the user can safely ignore? So there are several classifications. And I'm listing this as 2 items because they are different. An error doesn't mean that the program should terminate. The warning doesn't mean that you should move on. They're just orthogonal to each other, okay? And then there are still several things that you might want to include in a compiler diagnostic. For example, a Googleable code, because why? Well, when the user sees an error message, what they're going to do is to copy the part that they think that is the most important from the screen, and then put it into Google, and maybe after some clicking, then focusing on the Stack Overflow website or whatever that is there. Maybe in near future there will be some website powered by the ChatGPT or something like that. Okay, but anyway, they're going to have some keywords. So if you can put in some very unique ID that is recognized as one single word by Google or whatever search engine, it will be very helpful for the user to identify, to locate the documents. And this has been used by Rust and many other languages. And I think that is actually a very good convention to keep. The other thing is then a user perceived stack backtrace, the traces, like why this error has happened. And I want to make another clarification here. It's not a code backtrace. Because the user doesn't care how it's really implemented in your code. You might have like 10 different helper functions in order to implement one thing, the one conceptual idea, but the user doesn't want to know that, in order to infer the type, I called another function to infer just for pi type, and then infer whatever, right? So you don't want to understand the detailed backtraces of the thing because to the user, it's not very helpful to really understand how your code works internally. Okay, they want the conceptual reasoning about why the error happens, and they are different. Yes?
So it's a backtrace into what? Into like ideal implementation of the
So that's an interesting thing. So it's more like you have to describe at a higher level, like what you're doing. For example, you might say that I'm trying to infer the type of this term, but not in terms of I'm calling this function for this argument and then calling then another function with that argument, because the user couldn't understand like what you're doing. So this is really a backtrace, but at a higher level, trying to describe what you're trying to do at a higher level, and which might not match the code stack. Yeah. Okay. And the final thing is to allow multiple spans. Now, by a span, I mean a part of the source code. Why does it matter? So that's just so many instances. So I was actually surprised when I think I got a question about this. But anyway, so for example, if you have a pattern matching and you want to say that the type of the branches don't match, you might not want to just pick the first branch or the last branch. You should just highlight all the branches, right? And then say they don't have the same type, for example. So that's one instance. And you can probably come up with many more usage of the multiple spans. But the gist of it is that it's in particular for a general library, we should be able to support multiple spans as our representation of a diagnostic. Okay, so we think these are really crucial parts for a good diagnostic. And then there's many other designs. So this talk will really just be our own ranting of like how other people might have been doing wrong. Okay. So, for example, like, okay, actually this, I don't have a standard answer for this, maybe later slides. The other thing that you have to consider about the compiler diagnostics is whether your message is structured or not. So let me show you what we mean by that. So 100% structured is that, for example, in a language such as Haskell or OCaml, you can have an inductive data type give you a very rich representation, and you can very well just define a type representing all the possible errors in a very structured way. Like everything has come with its own constructor and so on. So I'm going to call it like 100% structured, and the 0% structure is like just a string or something like that. And you might want to stand in the middle, which means that, for example, in this case, there's a type error. Okay, but I'm not going to specify, like, I'm not going to give a unique constructor for every kind of type error. I'm going to have a type error, but then all the remaining additional information as string or something like that. So I'm going to say that it's somewhere in between. And it's not an easy decision to make, like, what should be just a totally unstructured strings and what should be a dedicated, unique constructor. But I'm going to just provide some of our thoughts. We do believe that some structuredness does help the user. In particular, the code that I was talking about that user can Google, that is part of the structuredness. So some category classification should help the user identify, or by identify I mean Google, okay? Nowadays, identify means Google. So they can Google the pages they want to look at. However, if you go all the way with full structuredness, I think in practice you are going to encounter difficulties in many cases. And one of the significant cases, in my opinion, is the parsing. Because there are so many different possible errors due to parsing. Maybe unmatched symbol or something missing or something expected, and you are going to do that, or some lecture looking for something in the end of the string and it's not going to find it. For example, that you can come up with so many different kinds of errors, and I think it's very annoying if you're trying to define a very precise data type with a unique constructor for every single case. So maybe this is a case where you just want to have a parsing error and then have all the rest as a string or something like that. So it's something you can think about. So which one? Well, we support both the fully structured and the 50% style in our library. So we actually design our library very carefully so that it actually makes sense in both usage. It's not an easy design. We have to sometimes argue with our intended user to say, no, I think this doesn't make sense. The user says, yeah, I want it. And then anyway, we came up with some design that I hope that is reasonable. Okay, now I think I'm going into the territory where I'm going to have more and more rants and maybe jokes. So the first thing is compositionality. This is something we want to really uphold in our library design. So the typical thing that you might be thinking about is that your main program is using the library. And if we manage to convince all of you to use our library, in near future, we are going to have libraries that are also using this asai as error reporting. So it's important that to be able to use a library that is using this library and then somehow combine all the error handling together very nicely. Okay, at least that's what we believe that should be important. And it's not just using one library. How about using another library? And what if there's a library that is using another library? So we have been, I don't want to show you the API now, but we have been taking lots of time making sure that this is easily doable, like almost trivially. Okay, so, all right. Let's see, I think I'm going to really have a first big rant. Okay, I need to get ready. Okay, the first thing is Unicode. So this is, by Unicode I mean typically non-ASCII things, but actually everything is just Unicode. So here I have some characters on the screen. So ABC, and then there's a Zhongwen here, which is in Mandarin, but it doesn't really matter. It can be any script. And then there's an emoji in the end. So in the past, people have some ideas about column numbers. Column numbers means, well, with the position on the screen there, right? But how about this, right? Is that 4? Like, how about this? Is it 5? Or 1, 2, 3, 4, 5, because this is wider, right? So already the introduction of all these fancy characters is going to screw you up. And it's not just like that. You might think, okay, maybe I can come up with a heuristics, kind of a database to say that, okay, this is wider and this is thinner and et cetera, et cetera. Maybe I can get along with this. I'm going to show you that. Good luck. Okay, so the next thing that I want to show you is that there's something called scalar value, and this unfortunately is a terminology that even I think the people in the Unicode committee might have trouble with. So I'm going to call it just Unicode character. It's not an official term, but I think it's better understood. Okay, and there's one Unicode character for this little a and little b and little c, and this entire thing is one Unicode character. But this emoji that I handpicked actually consists of 3 Unicode characters. I just want to show you how horrible the situation is so that you can give up, okay? It's not, the details are not important. So if at this point you feel like, okay, too much, please stop. Yes, that is exactly the message I want to give you. And if you haven't given up yet, please follow me so that you can really give up. So what is this 3 in this pirate flag? It actually consists of a black flag with a 0 width joiner, which is a special Unicode, which consists to like 0 width, and then with a skull. And this is kind of joining these 2 things to form the pirate flag. Why am I showing you this? Because the database approach will give you this as some kind of wider thing and this, right? And then if you are naively thinking that, well, I can just add up all the widths of individual characters, good luck. Okay, if this is still not convincing enough, please talk to me offline. I think we need a conversation. Okay, but the point is that there's no easy way to predict how wide anything it will be actually on your screen. It depends on your font, the font. It depends on the terminal. It sometimes depends on the locale. It's very complicated, and we don't want to go into the details. And then many programs use some in my opinion, broken heuristics in order to guess like how wide it is. Yes?
So yes, for example, if I want to send my diagnostic to an LSP server, if I want to send my diagnostic to an LSP server, they have expectations about how they measure positions. So is it possible to at least respect that from using your library?
Okay, so we have managed to come up with other way which do not depend on the visual widths. So that's our solution.
But is there enough information in an asai report so that I can at least give the position to the LSP server that they expect, so that they do something useful with the diagnostic?
I see. Okay, so the more technical answer is that the LSP is actually not using visual widths. It's using the number of units in the UTF-16 encoding. So I'm going to just say that this is, for example, the 1, 2, 3, 4, 5, 6, 7, 7th code point. I'm not talking about the visual width, but I'm talking about some kind of unit in some encoding. So in that way, I'm not referring to the how wide is it really on the screen, so I can avoid this problem. Yeah, so there is a way. Just forget about visual width. Okay, forget about visual width, and you'll be okay. Yes.
In the program, I use the zero width symbol to just hide arbitrary code inside the pirate flag.
A second.
So can the program use the zero width character on its own to sort of hide code, let's say, inside the pirate flag?
Okay. So let me just bump up the game even further. There are ways to even change the direction of the characters from right to left, inside the left to right, and then inside the right to left is recursively defined. So you can have a program where if you naively rendered, it will even change the semantics of program because you are going to render, for example, the different cases of the pattern matching differently. Yeah. Okay. Is that cool enough? Okay. There was some Unicode recommendation. Yes, Unicode is very horrifying. So we haven't even touched that part yet. Just don't have any naive assumption about Unicode. Every assumption you are making is basically false. Yeah. Yes, I can justify that. Okay, this is the biggest rant ever, and then so this is some messages from relatively naive tool. So you're going to have using this ASCII, right, to kind of guess, like, to approximate the visual length. And as I just show you, this is just mathematically impossible. So we just feel like, no, we don't want to do it, and we are going to uphold this as much as possible. So if your tool doesn't work for emoji, then it doesn't work. Okay, that's it.
So what do you do instead?
Oh, we're going to, okay, I'm going to have a demo in the end.
Okay, cool.
Yeah, okay. So, and the other thing I want to share with you when we are working out the design is a tutorial-oriented design. I think this is something we learned. So we write out a tutorial, like this link, and the point is that if you couldn't write a tutorial, then your design, in my opinion, is just bad. Like if you want to test, like, does this API make sense? Well, try to write a tutorial. And if you could explain it, good luck. But if you couldn't, then you have to go back to the design and change it. And we're going to call it rubber duck design method. I mean, there's a rubber duck debugging method where you just have a rubber duck and explaining why your program makes sense to the rubber duck. And here it's basically the same thing, right? You are explaining to a rubber duck why your API makes sense. And if you couldn't do it, you should change your API. So I think this is one of the meta principles we are holding. What else? Okay, so this is some OCaml library just came out very recently that is called Grace. It's very similar, but since it came out, I think I will have to put on some related work section. So this is one of the latest slides I just put in. So it's very similar. It's just our representation is based on the LSP. LSP stands for Language Protocol. And then the Grace is inspired by Rust. So we have different representation but otherwise very similar. And we are using algebraic effect to generate this diagnostics. So there's lots of care to make sure that it's kind of easy. I'm going to show you easy to generate the diagnostics. And I don't think Grace has something as fancy as ours. And the rendering, we are basically focusing on emoji. Emojis is the only thing we care about. And Grace is embracing more the traditional view of the diagnosis and then having all these ASCII R's to point out where it is. Okay, so but our design, both libraries actually separate the rendering from generation. So after running some bridge code, we can actually use Grace to render our diagnostics and vice versa. So there's no fundamental incompatibility, between these two libraries. Okay, I'm almost done. So I have some success stories that I want to share with you. Well, first of all, we actually just created a prototype to make sure that we are not lying to ourselves, that it's working, and it appears to work with our prototype. And then there's some interesting customers of our libraries. One is that John Sterling actually just created a tool to generate his website. What else can be better than your own tool, right? So he created this, and the point is that it's not a proof assistant. We created it for proof assistant, and then we insist that it should work for emojis, but then it turns out to be also useful for other things. And then there is a work in progress type checker by Max Schulman on the HOTT. This is not public yet, but it's public that he's working on this non-public project. Okay, and then we are basically looking forward to more customers of this library, and because we actually learn a lot from our users to improve our design. Their feedback is really important, and we also want to hear from you. So I would like to invite you to consider our library in the future when you are creating your own tool. So this is, I think, the shortest URL that I can come up with. Okay, I think I have 2 minutes, so I can really show the thing. Let's see. So, I thought I need a Q&A for. Oh, I thought it's 20. Oh, yes. Okay.
Can you make the font a bit bigger?
Yeah, but can I switch your mic to this? Okay. Right. So the thing is, in order to use this library, first of all, you of course using OPen install asai or something like that. But I'm going to skip that part. The actual change you have to make to your code is to create a module like this. Okay. There are 3 things here. The first thing is to define a type T that is basically kind of the data type I'm talking about to represent all your possible errors.
Why doesn't unbound variable carry the variable name?
Wait a second?
Unbound variable should be off string or whatever.
You could do that, and that would be more structured, but you also don't have to do that because we do have another way. You can just attach that as a part of the unstructured part of your diagnostic. You can also just put it in structured. As I said, we designed the API carefully so you can just do your own style. So this is a very relatively unstructured, right? It only has some very rough classification of the errors, but that's okay. And then you have a default. Basically, this is to tell the user how serious it should be, and we just said everything is an error. But it's a pattern matching function, so you can just map, for example, type error to a warning if you want to, or something like that. And I actually didn't expect I would have time to explain the code. So I apologize if I appear to be unprepared because yes, I am. And then there's a shortcode. This is to map every error to Googleable term. And if you feel like, okay, Favonia, I cannot remember this. Remember, we have spent all the time writing out a tutorial which explains every step you have to follow. And actually, it says much more than I do now. Okay, so you have this module, and then finally, you just include this, and this is a function which takes your definition of error message, and now you are ready to go. Okay, so this is I think very easy to adopt. So now I'm going to change the main file. So this is a file where you are going to add in the generation of the error message and other things. So this is a typical, let me actually zoom out a little bit. So this is a typical, just a very simple MBE for, actually not MBE, bidirectional type checking for the lambda calculus. And then there are two things that you can do. So I'm going to search for reporters. So one thing is that you can report an error. Well, yes, because I mean, what's other thing this library should do? So you can have a report fatal, and then this will be, the first argument will be the thing you just defined. So what the error is, and then here is unstructured part. And you can see that you can even have a formatting because that's the F variation. So we really try to make your life easy, okay? So if it's just a string, you can just have a fatal, but if you want to have a formatting, you can have an F version, like print F, just like F, which allows you to have this kind of formatting. And then how do you generate the semantic backtrace? This is done by calling this trace function and just putting this will be the content of the frame. So it means that when you're calling this function, you're going to push a new frame in the backtrace, and when eventually all this backtrace will be collected and then printed out in the renderer, okay? And then what else? So you can just go through this file and then put in the fatal F or emit F or whatever to the places where you want to report the error, and then add a trace to the places where you want to create a new frame in the backtrace. And then finally, you just, let me scroll down, and then you have just use some algebraic effects to kind of pick a renderer. I know this, I don't expect that any of you can understand the code right now, okay? And then that's why we have a tutorial. You can just pick a renderer, and that will print out everything on the screen. So I'm going to just show you what will happen on the screen. So, but the main message is that you don't have to do much in order to adopt this library. So after all this work, this is an exciting part. So I think because everything is expected to fail during live demos. Actually it works. Why? I don't. Okay. So here is an error message. It's saying that this doesn't have the correct type. This is checking. This is bidirectional type checking. And you see that we're using the coloring and underline instead of color number to overcome the Unicode problem. And this is saying that when checking this against this type, and then you go into the term, and eventually the actual error is here is that saying this is not in the scope, okay? And you don't have to worry about this fancy ASCII art. We are already done that for you. You only have to provide the content of your message, and we are going to put together everything that you have told us to render it beautifully on the screen. So that's what we have done for you. So please consider this if you want to have this, okay? Yes?
So suppose I have like a type checker written in monadic style. Yeah, so I have some type checkers. They're all written in monadic style. If I add asai, will there be like bad interactions between like effect handlers and the kind of monadic style programming, or do I have to switch to using effect handlers as well?
Oh, that's an excellent question. So unfortunately, the interaction with the monads and algebraic effects, or in general any kind of like exception and also algebraic effect both, they do not interact very well with monads. And I don't feel this our fault. It's some kind of fundamental limitations that maybe someone should publish a proper paper to deal with.
Okay, so we're pretty much out of time. There's time for a quick question, I think. Go ahead.
So, asked about column numbers, and you said you're going to show us. So you showed us, right? You're going to change the colors and do the underlining, which you presumably do by sort of fumbling around in some Unicode string and adding extra characters that do underlining and coloring. So your library somehow does that. How do you? What's the generic way, application independent way that you manage to do this coloring and underlining business?
So underline really depends on the actual renderer. For the terminal renderer, we're using there's some there's some ASCII control code that you can use to change the color. So that's one way. If you're using HTML, then there are other ways to do it. It really depends on what kind of backend you are using. And for terminal, I think this is the best way that we can find without depending on the color level.
Maybe I can ask in a different way. So this backend thing that renders it, right? The renderer must have some input that is kind of like the original program, and then some spec for which bit should be underlined.
Oh, that's a
right? What is the spec if not column numbers?
Okay, we're using bytes because bytes is the most efficient and the best way. And we have a section dedicated to why all other choices, in our opinion, are worse.
I see. So sort of byte offset in the original
Byte offset.
string.
Everyone should use byte offset. Really, seriously.
That was the missing piece of information. Thank you.
Okay, I see.
Okay, this will need to be the last question, I think.
Thanks for the talk. That looks really great. 2 questions. So first, is it an OCaml specific tool? Like, can I use it from other native languages or perhaps JVM-based languages?
It's right now written in OCaml, but I believe the design is not dependent on the language. It's just that we love OCaml, so we use it. But I think the design is not specific to OCaml. Yeah. So feel free to copy the design, and we want to you might have to if you want to copy really the entire design, yes, but I think you can still use Monad to do this. What's the second question?
And the second question is, so the thing with like error F or trace, it reminds me a lot about the logging I would add to my type checker. So like, what's the reasoning? Like, what if I want to have both the logging and this form of like fancy error reporting?
So what you want to do is to go to our GitHub issue, because there is an issue trying to create the best API which does both. Because it's very similar to logging, but logging is for developers and diagnostics are for users, and they are different things. But often the developer want to see both and more, right? So we should be able to use the API in a way that the diagnosis is actually part of logging. And that is what we are working on right now. So there's a GitHub issue, and please join the discussion and give us feedback. Thank you.
Okay, thank you very much, Favonia. Let's thank the speaker.